Now let's look at independent and dependent events. So independent events are events that are not impacted or affected by previous events. Okay, so if you flip a coin and then roll a dice, okay, the flipping the coin has no impact on rolling the die. If you choose a king from a deck of cards, put it back in the deck, and then choose another card. Spinning a spinner and then rolling a die. Like those are things that have no impact on the other one. Dependent events are where what happened before will impact what happens next. So we did a couple examples with marbles. So let's say we pull a color out of a bag and we don't put it back and then we choose another marble. That will impact the probability of the second event. Same thing with a deck of cards. If you choose a number, you choose a card and leave it out of the deck and then choose another card, that will impact the probability. So we'll do a couple examples of these, determine whether they are independent or dependent, flipping a coin for heads and spinning a game spinner for $500. Okay, these are independent events because flipping the coin has nothing to do with the spinner. So that is independent. I need a better color. All right, drawing a spade from a deck, keeping it, and then drawing a heart out. So if you take a spade out of a deck of cards and you leave it out, it is going to impact the probability of that second card. So this would be dependent. Now, if you put it back in the deck, then it would become independent. So when you do not replace, you'll see those words a lot, that is going to be an indication that it's a dependent event. Okay, so this leads us to compound probability. So when the events are independent, when you're trying to find the probability of A and B, you will multiply those two probabilities together. So the probability of flipping a heads and rolling a 3 on a die. So flipping a heads would be 1/2, rolling a 3 would be 1/6, so you would do 1/2 times 1/6, and that would give you your probability. Okay, but let's say the independence or the events are dependent, then to find the probability, you'll find the probability of the first event like normal, but then you're going to multiply by the probability of B given that A has already happened. And I think that sounds a little weird, but when you see the example, that will make a little bit more sense. So let's look at a couple examples. All right, so you roll a die with sides numbered 1 to 10 twice. Find the probability that, okay? So we need to decide, are these events independent or dependent? Well, when you roll a die, the first roll has no impact on the second one. So these are going to be independent. So I'm going to go ahead and answer part C first because that will help us with part A and B. Independent, the first roll does not impact the second roll. You could say that in a couple different ways. It is probably the most straightforward way. Does not impact. All right, so let's find the probability we roll a 5 and then a 7. So the probability that we roll a 5 is 1 out of 10. Keep in mind this is a 10-sided die. And, so we're going to do multiplication, and not or. A 7 would also be 1 out of 10. So multiply those together, we multiply straight across, that would be 1 out of 100, which does not simplify. Okay, what about you roll an even and then an odd? Okay, so rolling an even, there are 5 out of 10 possibilities, 2, 4, 6, 8, 10, and then an even, then an odd is also 5 out of 10, so we're going to multiply those together, which gives us 25 out of 100, which simplifies to 1/4. So significantly more likely that you would roll an even and then an odd compared to rolling a 5 and a 7 because there are more ways to get evens and odds, whereas there's only one specific way to get a 5 and one specific way to get a 10. I'm sorry, a 7. Okay, what about this example? It says a jar contains 5 red, 2 pink, and 3 white marbles. That's a total of 10 marbles. If a marble is drawn at random, returned to the jar, and then a second marble is drawn at random, find the indicated probabilities. Okay, so the key thing here is that it's returned to the jar, because what that means is that when you go to do your second pick, you have the same possibility as that first pick. So that is going to make this independent. So on E it says, does the selection of the first marble influence the selection of the second marble? That's no, and that's because the marble is replaced, which makes this independent. Independent. All right, so find the probability of a red and then a red. So we have 5 out of 10 reds times the second red, 5 out of 10. So that gives us 25 out of 100, kind of like the one we just did, and that simplifies to a fourth. All right, white and then pink. So white is 3 out of 10 times pink is 2 out of 10. So that's 6 out of 100, divide those both by 2, 3 out of 50. Both pink, all right, so that means pink and pink. So 2 out of 10 times 2 out of 10, 4 out of 100, which simplifies to 1/25 if you divide them both by 4. And then red and pink. So red is 5 out of 10 times pink, which was 2 out of 10, and that's going to give us 10 out of 100, which simplifies, divide both of those by 10, 1/10. Okay, so you might be reading this saying this is the exact same problem, but it's not. A jar contains 5 red, 2 pink, 3 white. If the marble is drawn at random, not returned to the jar, then the second marble is drawn at random, find the indicated probabilities. So because you do not put that marble back in the jar, when you go to pick your second marble, there are only 9 marbles to choose from. So that is going to impact the probability of that second pick. So these are dependent. And that's because the marble is not returned to the jar or not replaced. Okay, so both white. So white is 3 out of 10 for the first one. And then when you go to pick the second one, if you already picked a white, you now only have 2 whites left. And because you did not replace that white, there's only 9 marbles left. So the probability is 3 out of 10. That's picking a white out of the 10. You took that white out of there. You only have 2 whites left and only 9 marbles left. So that gives you 6 out of 90. And 6 out of 90, both of those are divisible by 6, which gives you 1/15. Okay, probability of white and then red. So like A, there are 3 white marbles, so 3 out of 10. So you picked a white marble, you took it out. That doesn't impact the number of red marbles left. There's still 5 marbles left, but there's only 9 marbles remaining in that jar because you kept that one out. So 3 times 5 is 15, and 10 times 9 is 90. Those are both divisible by 15, which gives us 1/6. Okay, both red. So 5 out of 10 for the first drawn. And then you take that red marble out. So now there's only 4 red marbles remaining. And since you left that marble out, there's only 9 marbles left in the jar. So 4 times 5 is 20. And then 10 times 9 is 90. And that simplifies. Those are both divisible by 10, 2/9. And then finally, red and then pink. All right, so we've done red already. 5 out of 10, half of them are red. Pink. All right, so taking that red out doesn't impact the number of pinks. There's still 2 pinks left, but we do have that red marble sitting out, so there's only 9 total marbles left. So if we do 5 times 2, that's 10, over 10 times 9 is 90, divide those both by 10, 1/9 for the probability of red and then pink. Okay, so your key for dependent is when something is not returned to the jar, when your number of outcomes is going to be impacted by whatever happened first. All right, for this example, it says a school surveyed the student body and determined that 8 out of 10 students like pizza. If 3 students are selected at random, with replacement, what is the probability they like pizza? Okay, so the first student, the first draw, we've got 8 out of 10. That's our probability. We put it back so that doesn't impact the next one, so that's 8 out of 10. We put it back because it's replaced, 8 out of 10. So 8 times 8 times 8 is 512. 10 times 10 times 10 is 1,000. And this does simplify to 64 over 125. A player rolls a pair of 6-sided die. What is the probability of throwing 2 odd values? Okay, since it's a pair, one event is not going to impact the other, so this is independent, so we're just going to multiply the 2 probabilities. Throwing 2 odd values. Well, there are 3 odd values on one and 3 odd values on the other. So 3 out of 6 times 3 out of 6 is 9 out of 36, which simplifies to 1/4. What is the probability of throwing a sum of 7? Now this one's a little bit more complicated because you got to think about the ways to get a sum of 7. So let's say you throw a 1 on the first one. You would have to throw a 6 on the second one to get a sum of 7. Let's say you throw 2 on the first one. You would have to get a 5 on the next one. 3 and 4, 4 and 3. And then we're at 5 and 2, and then I did not leave myself with enough room, 6 and 1. So we have 1, 2, 3, 4, 5, 6 total possibilities out of 36. So that would be 1/6. The jar contains 5 red marbles, 3 green marbles, 2 yellow marbles, and 1 blue marble. So that is a total of 11 marbles. And we're going to find a couple different probabilities. So drawing a blue marble, all right? So this is just basic probability. There's 1 blue marble, so that'd be 1 out of 11. Drawing a red or a blue marble, all right? Well, drawing a blue marble is 1 out of 11. Or means we're going to add. Drawing a red marble is 5 out of 11. And this is mutually exclusive because you can't draw blue and red at the same time, so you don't need to subtract anything that overlaps. So this is just 6 out of 11. Drawing a marble that is not red or yellow. So you can do this a couple different ways. I just look for the ones that aren't red or yellow, so that would be green, which is 3. And blue, which is 1, so that would be 4 out of 11. Drawing a purple marble. Well, there are no purple marbles, so that would be a probability of 0. It's impossible. Drawing a blue marble, replacing it, and then drawing a yellow marble. So you're picking 2 marbles. So let's start with blue. Blue is 1 out of 11. You're going to multiply it because it's and 2 draws. A yellow marble, because you put it back in, there are now 11 marbles back in the jar, so there are 2 out of 11 yellow marbles. So if you multiply that together, that's 2 out of 121, which does not simplify. Okay, draw 2 red marbles with replacement of the first marble. So you draw a red marble, which would be 5 out of 11. You put it back in and draw a second red marble, which would be 5 out of 11 again. So 25 out of 121. All right, drawing a yellow marble, then a blue marble, and finally a green marble, all without replacing. So you do not put them back. So we start with yellow, which is 2 out of 11. We keep that yellow one out, which does not impact the 1 blue marble, but it does impact how many marbles are in the jar. Now there's only 10. And then we pick a green. There's still 3 green in the jar, but now there's only 9 marbles in the jar. So if we multiply those together, 2 times 1 times 3 is 6. And then out of 11 times 10 times 9, which is 990. And that actually does simplify. They're both divisible by 6 to 1 over 165. All right, drawing 2 red marbles without replacement of the first one. So we pick a red marble, which is 5 out of 11. We keep that red marble out. So now there's only 4 red marbles left out of 10 marbles. So 20 out of 110, and then divide those both by 10, so 2 out of 11. Last example, a nationwide survey showed that 75% of teens in the United States own a smartphone. If 5 teenagers are chosen at random with replacement, what is the probability that all 5 own a smartphone? So 75% is the same thing as 0.75. And you're just going to multiply that for all 5 teenagers. And you could, if you want to do, you could have also changed it to a fraction, do 3/4. But this is going to be pretty gross looking decimal. So 0.237304,688 keeps going on, and we're just going to round this to 0.237. Typically with probability, if we have a decimal, we'll round it to 3 decimal places. But you could also have done 3/4 times 3/4 times 3/4 times 3/4 times 3/4, or 3/4 to the 5th. And if you did it that way, it would be 243 over 1024. So that's 3/4 times 3/4. Either way would be acceptable.